Welcome to the .NET MAUI Scheduler tutorial. In this video, I will demonstrate how to book appointments using the AI service in the Syncfusion .NET MAUI Scheduler. I open an existing MAUI application. Here, I have already configured the .NET MAUI Scheduler control and specified the appointment for each doctor. To learn how to add the .NET MAUI Scheduler control to your MAUI application, watch the video linked to the YouTube card above or the description below. Now I run the application. You can see that the appointments are displayed for each resource. I will demonstrate how to book appointments using an AI service. Within the grid layout, I first create an AI Assistant button that opens the AI Assistant's user interface panel, which will be displayed at the top right corner. The button is customized with specific styling, including size, color, corner radius, font family, and alignment to make it visually appealing. Then, I create a border and add a grid layout to design the AI Assistant header UI that appears when the button is clicked. Within the grid, I will add a label and set the text to AI Assistant, which will serve as the title of the Assistant panel. Next, I will show you how to check the availability of doctors and schedule appointments using the AI service. I will begin by integrating the AI service into the application. First, I open the NuGet Package Manager and switch to the Browse tab. I search for the Microsoft Semantic Kernel NuGet package, select it, and install it in my project. In this example, I'll focus on using Azure OpenAI, but you can choose any chat completion service. If you decide to use Azure OpenAI, ensure that you have access and set up a deployment via the Azure portal. After installing the package, I create an Azure OpenAI service class to handle interactions with Azure OpenAI. I begin by declaring three constants: endpoint, which specifies the Azure endpoint URL for API calls; deployment name, which refers to the name of the AI model; and key, which is the API key for authentication. These values are essential for connecting to Azure OpenAI. Next, I declare private variables to manage the OpenAI kernel, chat history, and completion services. I'll define chat completion to handle chat responses, kernel as the core handler for AI requests, and chat history to maintain a log of the conversation history. To initialize the Azure OpenAI kernel and set up the components required for interacting with Azure's OpenAI services, I create a getAzureOpenAI kernel method and call it in the constructor. In this method, create a new chat history instance to store conversations. I use the createBuilder method to configure the AI model and set up the Azure OpenAI chat completion service by specifying the deployment name, endpoint, and API key. Once everything is configured, I build the kernel to finalize the AI setup. Next, I retrieve an instance of the AI chat completion service from the kernel to generate AI responses for the chatbot. To send a user's prompt to Azure OpenAI and retrieve an AI-generated response, I create a getResponseFromGPT method. First, I check if the AI response generator and conversation log are not null. If they are, clear the chat history to start fresh. Next, I set the AI's role by adding a system message to make it a predictive analytics assistant. Then, I add the user's question to the chat history. Within the try block, I call the getChatMessageContentAsync method, which sends the chat history, an AI processing unit to the AI service to fetch the response based on the conversation. When the AI generates a response, convert it into a string and return it to ensure that it is readable. In the catch block, I simply return an empty string to prevent errors from affecting the process. Next, I move to the main page CS file and create an appointment model class to facilitate appointments booking. Then, I navigate to the Scheduler View model class to manage appointments, AI responses, and handle scheduling logic. I declare a return message field to store the AI-generated response after requesting data from OpenAI. I also declare a messages collection containing the conversation messages between the user and the AI, and I initialize it in the constructor. Additionally, I define a showHeader field which controls the visibility of the header in the user interface, and SfAIAssistView, which manages the visibility of the AI assistant. I create an instance of Azure OpenAI services to handle AI responses using the OpenAI API. Now, let me show you how to store the appointments. I create separate lists to store the appointment details for Dr. Sophia and Dr. John. To integrate AI-powered assistants into a scheduler appointment application, I create a class called AssistViewBehavior that extends the behavior of SfAIAssistView. In this class, I define private field, AssistView, to hold a reference to the SfAIAssistView instance. I also define properties that connect the behavior to the scheduler control and its view model. I define an onAttached method that runs when the behavior is attached to an SfAIAssistView component. In this method, I call the base class's onAttached method to ensure that the base behavior is initialized properly, and store the reference in the AssistView field. Next, I check if AssistView is not null, and subscribe to the request event, binding it to the onAssistView request method. Whenever the AI AssistView receives a request, the onAssistView request method will be triggered. Similarly, when the behavior reverts, I unsubscribe from the request event. In the onAssistView request, I set the showHeader property to false to hide the header of the scheduler view. I extract the user's request text and assign it to the request string. Then, I declare variables to store appointment details for Dr. Sophia and Dr. John to hold appointments start time, end time, subject, location, and resource ID. I check if the user request is empty and return without processing it further. Then, I use regular expressions to verify whether the request contains a valid time format like AM or PM. Next, I check if the request string matches. If it does not match a valid time format, I call the getAIResults method to process the user's input using AI. I move to the scheduler view model class. In the getAIResults method, I first create a delay to simulate processing time for the AI response. Then, I call the getRecommendation method to handle the query and return an AI-generated reply. Now, let's move on to obtaining AI recommendations for appointment scheduling. Before proceeding, ensure that you have installed the Newtonsoft JSON package. I start by storing today's date to use in the AI-generated schedule. Then, I construct a prompt with specific formatting and content rules for the AI. The appointments must be 30 minutes long, include specific fields, follow a JSON format, and exclude any extra characters or explanations. I send this prompt to the Azure AI service and await the response. Since the AI often wraps JSON in Markdown formatting, I remove those wrappers and trim any white space. I also use a regular expression to replace the datetime format, making it easier to parse. Next, I parse the clean JSON string into an object for structured access. Then, I create a dictionary to store appointment details for both doctors, using lists to hold start times, end times, subjects, locations, and resource IDs. I use a for-each loop to iterate through both doctors and extract each appointment's details from the JSON response. I convert the start date and end date strings into datetime objects and store them. Then, extract and store the subjects, locations, and resource IDs for each appointment. I assign Dr. 1's extracted appointment data to Sophia's properties, and similarly, store data for John's properties. Next, I create separate methods to filter John and Sophia's appointments. Here, I remove any conflicting appointments by checking the existing booked appointments in the scheduler, and call this method within the getRecommendation method. I convert Sophia and John's appointment start times into readable time slots, and assign them to Sophia available time slots and John available time slots. Finally, I create the generate final time slots method to format and return the available appointment slots for either Dr. Sophia, Dr. John, or both based on user input. In this method, I check if the user's input contains the word Sophia. If it does, I return a message saying, Dr. Sophia available appointment slots. If the input doesn't mention Sophia but does mention John, I return a similar message for John. If the input doesn't mention either doctor, I return a general message indicating that both doctors are available. This method is then called at the end of the getRecommendation method to generate the final output message. In the getAIResults method, I create an instance of SfAIAssistItem and an observable collection to store individual suggestion items. If the query mentions Sophia, I iterate through all of Sophia's available time slots and add each one as a suggestion. If the query doesn't mention Sophia but does mention John, I do the same for John's time slots. If the query doesn't mention either name, I add all of Sophia's and John's time slots, prefixing them with their respective name. I assign the list of suggestions to the Chat Suggestions object and set the layout to vertical so they appear in a neat column. Finally, I create an instance of AssistItem and include the AI's reply, the suggestions, and hide the footer for a cleaner look. I add this message to the chat history so it appears in the conversation. Next, I navigate to the onAssistView request method. In the else statement, I check if the request string starts with John and remove that part from the beginning. I also check if it starts with Sophia and remove that part as well. Next, I iterate through Dr. Sophia's available time slots. I convert each available time slot to a string and compare it with the request string. If a match is found, I proceed to book an appointment. Here, I retrieve the matched time slot's start time, end time, subject, location, and resource ID. Then, I call the appointment booking method to schedule the appointment. This method is responsible for booking online appointments by adding new appointment details to the scheduler. In this method, I assign the start time to display date. Next, I create a new scheduler appointment object and add it to the appointments list within the scheduler view model. Then, I define the time, purpose, and location along with the resources IDs to group appointments by different resources in the UI. Additionally, I set the background color for appointments based on the resource ID. Following this, I create a utils class to define a static helper method called addRange. In this method, I iterate through each item in the provided items collection and add them to the collection one by one. I return to the appointment booking method and cast the appointment source to an observable collection of scheduler appointment. Then, I use the addRange method to add all appointments at once. In the onAssistView request method, I create a delay to simulate the booking process. After this delay, I generate a chat message confirming that Dr. Sophia's appointment has been booked, and add this message to the scheduler view model's message list, which updates the UI. If no match is found, the loop continues to the next iteration. I repeat the same process for Dr. John. Now, I navigate to the main page CS file to implement the AI button. Here, I declare a private field to store references to the SfAIAssistView. When the panel appears on the screen, I want to locate both the AI and header views. So, I create a method called onAppearing. Within this method, I call the base function and search for the AI assistant and header views by their names in the XAML file. In the method that handles the AI button click, I first ensure that both the assist view and the header view exist before modifying them. Then, I retrieve the current visibility state of the assist view and update the visibility of both the views to ensure that the elements appear and disappear together. Finally, I move to the main page XAML file and define the SfAIAssistView control to provide users with intelligent suggestions for scheduling their appointments. I place it in the first column of the layout and add a top margin of 100 units to position it appropriately. I control the visibility by binding the showAssistView property, which dynamically shows or hides the SfAIAssistView based on the interaction. I set the horizontal options to fill to ensure it occupies the available horizontal space. I also assign the showHeader property to determine whether the header should be displayed, and I bind the assistant's messages to a collection of AI-generated responses. I define a behavior property and add the AssistView behavior class. I connect the behavior to the scheduler's data model and link the AI assistant directly to the scheduler component. This integration allows the AI assistant to read appointment data, provide suggestions, and update the scheduler dynamically. I define a custom header template, along with the data template. Within the vertical stack layout, I add a label with guiding text to help users understand the purpose of the AI assistant. To enhance the visual appeal, I add a subtle shadow effect, which gives depth and contrast to the AI Assist view. Once the application is loaded, I tap on the AI Assistant button, I check the available time slots, and choose one from the list. You can see that the appointment has been booked. Similarly, you can check the availability of each doctor individually and book an appointment based on their available time slots. You can see that the appointment has been successfully booked. Let me wrap up this video. You have learned how to book appointments using the AI service in the Syncfusion .NET MAUI Scheduler. If you want to see this example's working code, download it from the GitHub link in the description below. I have also included a link to check if you qualify for our community license, which gives you a free license key for our entire .NET MAUI controls. If you found this video helpful, click the like button and subscribe to our channel to watch more videos like this. Thanks for watching.